Good morning, folks. This is a short video to provide answers and context and maybe a little bit of additional instructional notions to evaluation 1, which was due as of last night. And so what I'll do is I'll simply walk through the answer sheet. As I said, provide a little additional information, a little additional instruction perhaps on some things, but it is primarily designed to help you review your submission so that you can see where you made mistakes or where you may have perhaps not been as precise as you needed to be. One of the things that is important in doing working with statistics and dealing with statistics is to be precise in terms of what the expectations are and precise in terms of what the questions are, and then very precise in terms of interpreting, what's in the data. We always like to say in stats, the data will tell its own story. You just have to read it correctly. And so what I'll do is I'll simply start walking through that now. I'm going to put it up on the overhead device I have here and simply work off of the text of the answer sheets. So give me just a second to share that up. Okay, maybe blow that up a little bit. So, the first one, get rid of some of this. The first question was a question about, what were the means and medians for the first two pretest measures. And I provided a couple of tables here. One because one which is out of JASP output, which will provide the framework or the set of answers for this particular question. And also I provided a handout of a printout from an Excel version of this. Some of these things can be done on Excel, and I know that there's one or two of you that may be trying to do that. I would warn you that as we move further along, you're going to have to come back to JASP because there are certain things that simply can't be done easily in Excel or provide way too much manipulation of the data to make it worth your time. So in terms of means, medians, standard deviations, you'll find outlined in yellow for the two pre-measures, pre-1 and pre-2. The mean for pre-1 is 9.78. The mean for pre-2 is 5.106. The medians are 9 and 5. Remember that the median is the point at which half of the cases are above and half of the cases are below. And so when you look at the difference between the means and the medians, in both cases, both these pretests, the means are, in one case, pre-2 slightly higher than the median, and in pre-1, perhaps a little bit higher than the median. And that would mean that these distributions are skewed to the high end of the scale or skewed to what we would call to the right of the distribution. Simply means that there are probably some outlying cases on the higher values that would drag the mean above the median. In a perfectly normal distribution, the means and medians would be equal. And then, of course, there are the standard deviations, 2.213 for the pretest 2 and 3.021 for pretest 1, which would tend to indicate that perhaps the pretest 1 scores are dispersed a little bit, have a little bit higher dispersion than the pretest 2 scores, which would also kind of indicate that the distribution for pretest 1 would be a little bit more spread out in terms of if we graph that on a normal distribution curve, and the distribution for pretest 2 would be a little bit taller and a little bit less spread out if we looked at the shape of those distributions. Minimums and maximums are really kind of meaningless things. They just tell you what's the lowest score and the highest score. And you'll find the difference between minimums and maximums and a question that's coming up in just a second. For question 2, my fingers to work. Once again, it's a question about just looking at descriptive information and finding the means, medians, and standard deviations for each of the 3 post-test measures. We looked at the pre-test, so now we're going to look at post-test, and they're highlighted in red, the answers. And so if you look at these post 1, post 2, post 3 means and medians differences, you'll see that post test 1, the mean and median are almost identical, which would probably indicate a fairly standard normal distribution. For post test 2, the mean is higher than the median, which would indicate a skew to the right or to the high end of the scale. And post test 3, the median is actually higher than the mean, which would mean since the mean is lower than the median, it would be slightly skewed to the left or to the low end of the distribution. When you look at the standard deviations, you would assume that post-test 3 is a little bit more highly dispersed than the others, and so there would be a kind of a wider, flatter distribution. Post-test 2 would be a taller, more compressed distribution, and post-test 1 would be somewhere in between, maybe perhaps more close to a standard normal distribution. Okay, let's move on to question 3. All right. Question 3 is one of those things that demands some precision, but at the same time also demands that you would have paid attention in class to our discussions about normal distribution and the way in which we arrive at the sort of the middle 95%, or the 95% that we would be assume is related to random error, and how we get at that number. And to get at that number, we actually need 2 things. We need a mean value, and we need a standard deviation value. And so the question was, what are the minimum and maximum change 1 scores that would define the middle 95 percentile? Minimum and maximum in this case does not mean the lowest score and the highest score. It means, you know, what are the 2 scores that are 2 standard deviations below the mean and 2 standard deviations above the mean, because 2 standard deviations above and below the mean define the middle 95% on individual z-scores. And this is kind of represented down here at the bottom. And so if you look at change 1, you would find a mean value of 1.712, a standard deviation of 3. And so if we would come down to the looking at the mean value, we're talking about a mean of minus 1.712 for a mean value, and the standard deviation would be a plus or minus 3.06 or 3.006. And so, you know, doing a little quick calculation of subtracting 6 from minus 1.72 give you roughly minus 7.724, and adding 6 to minus 1.712 we give you a plus value of 4.3. And so the minimums and maximums to identify the middle 95% would be minus 7.724 and 4.3. We would expect 95% of the cases to lie in between those two values, and in that case be what we would call in the range of random error. And so if you look at change 2, it's 1.606 and 3.073, and so it's 1.606 plus or minus 3.073, roughly say 6. And so 6 below that would be a minus 4.54, below 1.06, and 6 added to 1.606 would be roughly 7.752. And so those would be the minimums and maximum score for the middle 95%. And so you can't get caught up in just the terminology of minimum and maximum as a descriptive term. All that refers to is the lowest value and the highest value. What we really are interested in is what defines the 95th percentile. And so you have to be careful about how reading the language correctly. The third question is, or the next question is there a significant difference between gender on post-test 3? Let me drag this little screen out of the way. Post-test 3 score. And since this is 2 groups, male and female, on a comparing the difference between males and females on a continuous variable post-test 3 score, it is an independent samples t-test. And like all independent samples t-tests, the very first thing that we need to look at or understand is what is the p-value, what is the significance level. And in this case, the p-value is 0.927, which is not less than 0.05. And so therefore, it's not significant. And so there is no need to do anything else because it's not significant. So there is no significant difference between the means of males and females. And when you actually look at the descriptive data, you see that the means for females is 44.09. The mean for males is 43.94, almost identical. And the standard deviations are very close together, off maybe a half a point or so. And so it is not, there is not a significant difference between males and females. End of story, end of interpretation. The next item asks for, is there a significant difference between genders on pretest 1? Now this is a little bit of a kind of a trick thing, because it's not really a trick thing, but it's sometimes when you look at data, you don't really ask questions about the nature of the groups or things like that, and so the data can sometimes tell you what's going on. And in this case, the probability, the p-value between genders on pretest 1 is 1.0, which is certainly greater than 0.05, but it also tells us that the 2 groups are identical to begin with. And often what will happen is that when we are doing an experiment or doing a study, we will start with 2 matched groups. And we will match those groups based on some set of criteria, so that in this case it was based on their pretest scores, so that we were dealing with subjects that were not different from each other, at least in terms of gender, on pretest scores. And then we would be interested in seeing what happened as they move to their post-test values. And so asking this in terms of where the difference between gender was simply to highlight the fact that sometimes the data can tell us things about the setup of the study. And in this case, the only way you would have a p-value of 1 would be if the two groups are matched identically to begin with. And as you can say, they're matched on mean, but the standard deviations are ever so slightly different. So there were some other variations within the group that was not necessarily related to gender. And we weren't looking at anything else in this particular question except gender. And so the p-value of 1 means that they were matched to begin with on the pre-1 score. And so we took a group of males and a group of females, and we matched them on their pre-1 scores. Sometimes you'll match them, like 1-to-1. If you have a female that had a 90, you'll pick a male that had a 90. Or sometimes you'll match them on average. In this case, it looks like they were matched on average since their standard deviations are slightly different. But it is not unusual for studies to do that. And this was just a check to make sure that they were truly matched. Second question, is there a significant change from pre-1 or second t-test? Is there a significant change from pre-1 to post-test 2? And once again, this is a little bit of a teaching anomaly moment here. Since it's pre-post, since we're looking at a pre-value and a post-value, we're using a paired t-test. There is a slight difference in scale. And when you look at the mean value for pretest 1 compared to the mean value for post-test 2, you get the sense that there is a difference in scale here. Is that if you had the two instruments to look at, you would probably find that they're scored somewhat differently, even though there are pre and post. And often that may be the case that we're not careful about matching scales and pre to post. And so in this instance, if we follow just the p-value, we would say there is a significant difference from pre-1 to post-2, and we'd be correct. However, that when we begin to look at the means and think about scale and that sort of stuff, we begin to realize that probably we can't really know too much about what happened from pre-1 to post-2 because they were measured on different scales. And so the teaching point here is that it's important to have pre and post measures on the same scale. In other words, if we have a 5-point scale on one and a 10-point scale on the other, we're going to come up with differences that may be not meaningful simply because they're being measured on different scales. And so the important thing is when you're doing pre-post, a question to ask is, or a question to look at is, what's the scale of the two measures? Because it's important to have them on the same scale. But you can know that. So these are kind of the teachable elements I put into this particular evaluation. And then the last item on this evaluation was a one sample t-test, in which the question was if we know that the national average for a particular score was 49.5, are the subjects in this experiment or in this study significantly different from the national average? And in what way? Well, because we're comparing one group or a group to some sort of population mean or population parameter, we're interested in knowing, is our group different from the population? And since the population test was, just flattened out. Since the population test value was 49.5, and we know that the mean value of our group was 44.0. So therefore, we know that our group scored lower, and then the p-value, or the significance level, is 0.001, which means that it's obviously less than 0.05. And so the interpretation would be that this group of individuals scored significantly lower than the national average. Now, what that may interpret to, you have to know what the measure is. You have to know what, what's the nature of the measure, what's the scale of the measure. You have to know a lot of things about the individual instrument itself and what the measure is built on. But based on just the raw data, it is a significant difference, and our group is significantly below the national average. Okay, that's evaluation one. Let me get out of this share. That's evaluation one, and if the thing that you need to do is to go through and look at your submission, identify where you may have been gone off the rails a little bit. I suspect it had to do more with the minimums and maximums as anything. And once again, that was just understanding that there's another concept at play here, which is defined by the term percentile. And anytime you see the term percentile, you need to think of distributions. And in this case, the normal distribution, standard normal distribution of z-scores. And so, that was simply to make that point that you need to read carefully. And then, of course, the first two t-tests are really designed to spark in your mind the notion that you need to think about what these scales are, what these instruments are, what the values really mean. And the numbers are easy enough to interpret. It's just that, if you're actually working with data in this way, you also have to understand where those numbers are coming from, what the scales look like, and that sort of thing. But once again, that's not a mistake on your part. It's just this is an opportunity to make those points. And so that's evaluation one. And the upcoming set of assignments in the next 2 weeks, you'll find that you have 6 different examples and questions working off of a couple of different data sets. And it includes all of the things that were in this particular evaluation, plus information about analysis of variance and correlation and regression that you will find in the recording from last night's session, and examples that are up on As You Learn. If you need help or assistance or whatever, be sure to email me. If you run into problems working with JASP and haven't resolved those yet, certainly get back in touch with me so we can get you going in that, work you through, because as we move forward, you will find that you won't be able to do all of these assignments if you're trying to do it in Excel or some other similar sort of platform. So you need to be working in JASP. Plus the data sets that I'll provide you are JASP data sets. And so they will not naturally load into Excel. And so you'll have to convert to JASP if you haven't done so. And so if you're having problems with that, please get in touch with me and we can kind of work that out and figure that out. So that's the end of this recording. I'll get it up on YouTube and put a link up on As You Learn. Of course, you know that if you're looking at this. And, I'll see you in not next week, but the week after. And you have a series of assignments to work through between now and essentially when we meet again. So have a good couple of weeks and get some stuff done. If you have questions, email me, call me as a last resort, and we'll try to figure out what's going on and work through those. So have a good week.